Second same CSE, AIML or IT. Probability. First question, a bag contains 3 red, 6 white and 7 blue balls. What is the probability that 2 balls drawn are white and blue? First, 3 red ball. 3 red, 6 white and 7 blue. So total ball is 16. Out of 16, 2 balls drawn. So total possible case 16 C2. But 2 balls drawn are white and blue. So 2 white and blue. So the probability white and blue balls is equal to favorable case by total possible case. So favorable case means white and blue out white total white ball is 6. So out of 6, 1 white ball and out of 7 blue ball, total white ball is 6. So out of 6, 1 white ball is drawn. So 6C1. Total blue ball is 7. Out of 7, 1 blue ball is drawn. Means 7C1. By total possible case means 16C2. Using calculator, we get 6 multiply 7 by 120 means 40 by 120 means 7 by 20. So today I will discuss you about Bayes theorem. If A1, A2, AN, BA given set of n pairwise mutually exclusive and exhaustive event, then for any event A where probability of A not equal to 0, then 1 probability of A is equal to probability of A1 into probability of A by A1 plus probability of A2 multiply probability of A by A2 plus dot dot plus probability of AN multiply probability of A by AN. And number 2, probability of AI by A is equal to probability of AI multiply probability of A by AI by probability of A, where probability of A not equal to 0. So mutually exclusive term, mutually exclusive and exhaustive. I will discuss you what is mutually exclusive and what is mutually exhaustive. Mutually exclusive event means A1 intersection A2 is equal to phi, where phi equal means null. Suppose example, take exclusive events are two events that cannot occur at the same time. They are also known as disjoint event. Suppose the sample space is 1, 2, 3, 4, 5, 6 and A1 is equal to 1 and 2 and A2 is equal to 3, 4, 5, 6. So A1 and between A1 and A2 cannot occur at the same time. So A1 intersection A2 is equal to phi. Phi means null. And next one is mutually exhaustive event. Mutually exhaustive event is an event that cannot occur more than once at the same time. Take, take an example for Bayes' theorem. Two urn contains respectively 5 white, 7 black balls and 4 white and 2 black balls. One of the urn is selected by the toss of a fair coin and 2 balls are drawn without replacement from selected urn. If both balls drawn are white, what is the probability that the first urn is selected? Let A1 be event that the ball is drawn from first urn and A2 be event that the ball is drawn from second urn. So this is the first urn mean A1 and second urn A2. First urn 5 white and 7 black ball. 5 white, 7 black. And second urn 4 white, 2 black. 4 white, 2 black. There are two urn A1 and A2. So probability of A1 is equal to probability of A2 is equal to half. Let A be the event that two balls are white. Then probability of A by A1 is equal to 5C2 by 12C2, as total ball is 12 and out of 12, 2 white balls are drawn and total white ball is 5. So out of 5, 2 white balls is drawn. So this means 5C2 by 12C2. By using calculator we get 10. 5C2 means 10 and 12C2 means 66. So 5 33. 5 by 33. Again we calculate probability of A by A2. Total ball is 6. Out of 6, 2 white ball is drawn and total white ball is 4. Out of 4, 2 white ball is drawn. So 4C2 by 6C2 is equal to 4C2 means 6 and 6C2 means 15. 3 2 3 5. 2 by 5. By Bayes theorem, probability of A is equal to probability of A1 into probability of A by A1 plus probability of A2 into probability of A by A2. Probability of A1 means 1 by 2 multiplication probability of A by A1 is equal to 5 by 33 plus probability of A2 means half and probability of A by A2 means 2 by 5. 2 cancel. So 66 by 5 plus 1 by 5 by LCM 33. 5 5 25 plus 66 means 91 by 33. So our question is, what is the probability that the first urn is selected? So probability of A1 by A is equal to probability of A1 into probability of A by A1 by probability of A. Probability of A1 value is 1 by 2. Probability of A by A1 value 33 by 5. Probability of A value is 91 by 33. So 33 by 10 multiply 33 by 91. 10 10. 33 multiply 33 is equal to. So the answer is 1089 by 91. Thank Thank you for watching. A and B are independent event, then show that the following pairs are independent. Number 1, A bar and B bar, A and B bar. Number 2, and number 3, A bar and B. Since A and B are independent events, when P A intersection B is equal to PA into PB, I can write number 1, prove P A bar intersection B bar. As we know, A and B are independent events when P A intersection B is equal to P dot PB. So we can prove that P A bar intersection B bar is equal to P A bar dot P B bar. So now we try to prove that. So P A bar intersection B bar is equal to 1 minus P A union B. This is the formula. So we know that P A union B is equal to probability of A plus probability of B minus probability of A intersection B. So 1 minus probability of A plus probability of B minus probability of A intersection B is equal to probability of A into probability of B. So 1 minus probability of A, remove third bracket and we can write minus probability of B plus probability of A dot probability of B. First 1 minus probability of A, then probability of B common, taking probability of B common, probability of B 1 minus probability of A. Again 1 minus probability of A common, 1 minus probability of A and 1 minus probability of B. 1 minus probability of A means probability of A bar and 1 minus probability of B means probability of B bar. So A bar and B bar are independent. Then our second question is A and B bar are independent. We try to prove that probability of A and B bar is equal are independent. So probability of A intersection B bar is equal to probability of A minus probability of A intersection B. Probability of A intersection B means probability of A into probability of B. Now taking probability of A common, so 1 minus probability of B. Probability of A multiply 1 minus probability of B means probability of B bar. So A and B bar are independent. Now our third question is A bar and B are independent. With now probability of A bar intersection B means probability of A bar intersection B is equal to probability of B minus probability of A intersection B. Probability of B minus probability of A intersection B is equal to probability of A dot probability of B. Taking probability of B common, 1 minus probability of A. Probability of B dot 1 minus probability of A is equal to probability of A complement. So B and A bar are independent. For watching, please like, share and subscribe.